A hot Cheeto is thrown vertically upwards with an initial speed of 20 meters per second.
Draw a picture!
Alright, here's what's going on in the problem. Here's the ground. Here's the Cheeto that's getting thrown upwards. It's thrown upwards, goes up, reaches a certain height, and comes straight back down. It doesn't matter if this is a Cheeto, a stone, a ball, a potato, a whatever, the problem doesn't change. This could literally be anything getting thrown upwards through the air. Before I start, I'm going to call upwards positive in this problem. That's up to you. You can call downwards positive. I've just decided to call up positive.
2. Label your nose. Your knowns. Label your knowns.
So from the problem, we know that the initial speed is 20 meters per second. V naught, y, because it's vertical, equals 20 meters per second. I hope I'm not going too speedy here. And after reading the problem, you might think that's all we know because that's the only number it gave us. There's actually some things that we're supposed to infer from the problem without it directly telling us. Let's talk about the starting height. The Cheeto starts on the ground. So to make things easier, I'm going to call the ground 0, so that the initial starting position, or y naught, equals 0 meters.
Why not call y naught 0?
And the reason this is y is because we are talking about up and down stuff, and we represent up and down stuff by using y. So initial vertical position is 0. This Cheeto is on Earth, because as far as I'm concerned, I'm not aware of any other planets that have Cheetos on them. Because this Cheeto is flying through the air on Earth, the acceleration in the vertical direction is the acceleration due to gravity on Earth. So the vertical acceleration is equal to negative because I said up is positive, but the Earth is pulling downwards, so the acceleration is negative. Acceleration is in the direction that gravity is pulling. So negative 9.8 meters per second squared. I actually recommend using negative 10 meters per second squared as the acceleration. It makes the calculations easier. And you'll still get the right answer. This acceleration in the vertical direction is the same the entire time that this Cheeto is flying through the air. So even if it's on its way up, at the top, or coming back down, the acceleration is always the same. The acceleration is caused by the force of gravity. So because the force of gravity never changes, the acceleration doesn't change. So this value we can use throughout any point in the problem. Alright, now this is key here. The problem will never tell you this, but when the Cheeto goes up, it has to slow to a stop before it turns around and speeds back up and comes down again. So for a split second at the top, in order for this Cheeto to come back down, the Cheeto has to be at rest. The Cheeto has to come to a stop for a split second at the very peak. So the speed at the very peak of this Cheeto's path is 0 meters per second. And so I can write that as Vy equals 0 meters per second. Let's talk about what we're looking for. Part A asks, what is the maximum height that the Cheeto reaches? Our target is the maximum height. Y max equals question mark. We are looking for this peak height right here. All right, so this is pretty symbolic. Not just because there's a lot of symbols here, but because this is how you want to set up every single problem that you do. We have a picture drawn, we have everything that we know, and we have what we're looking for. So we can refer back to this picture at any time in the problem and use everything that we've listed here, and that's really helpful. All right, our next step is to find an equation that has the one variable that we're looking for in it and all the other variables in the equation that we already know. So if you look at your equation sheet, for any kinematics or freefall problem, you will use these three equations. So if I look at the first one, we do have a velocity, we do have a starting velocity, we have an acceleration, but we don't have a time. We don't know anything about time. And remember, we're looking for a maximum height or vertical position. I don't see the variable y in here, so that one's not going to work. Second equation. Remember, these x's can be replaced by y's. X stuff is just horizontal stuff. We're talking about vertical stuff, so really these should all be y's in our situation. So I have a position, a starting position, a velocity, a time. Oh, well, that's time again. We don't have time. We don't want time in our equation. I'm resorting to the last one here. I do know a velocity, I know a starting velocity and acceleration, and here we have a position, and we are looking for the final position or the max height. So this is the equation that I want to use, but I'm going to rewrite it in terms of y stuff. All right, part A. Our equation is vy squared equals v naught y squared plus 2ay times y minus y naught. Boom. Now we have an equation. All right, my next step is to plug in my zeros. So I refer back to my picture. The final velocity is 0, so I can cross that out, make it a 0. I see that the starting position is also 0 meters, so I can cross that out, call it 0. Now I'm going to rewrite this equation with my zeros in it. Our next step is to isolate the variable. What's our variable? Well, back in our picture, our target was the maximum y value. So we are looking for this y value right here. I want to get the maximum height by itself. So my first step, I'm going to subtract v naught y squared, and I'm calling this y max now because it's specific to our problem. Now I'm going to divide by 2ay. So I've isolated my variable. Now I'm going to plug in numbers. So y max equals negative v naught y. I look back at my picture, my initial vertical speed is 20 meters per second. So negative 20 squared. And so make sure that this negative is not inside the parentheses. You're not squaring that negative. That negative is there because you subtracted it. So make sure it's outside the parentheses. Divided by 2, and our vertical acceleration, ay, is negative 9.8 meters per second squared. Now I need to solve it. Now, if you don't have a calculator, you're totally welcome to call 9.810. It's almost the same thing. But if you want to be fancy and use 9.8, go ahead and do that too. You'll get it right on the AP test regardless. I get about 20. Uh-oh, that's not the right answer. If you leave your answer like this, you get the problem wrong. And that's because you didn't put units. We are looking for a maximum height. We are looking for a vertical position. And position is measured in meters. Before you present your answer, ask yourself if this makes sense at all.
I had a Cheeto that started from the bottom like Drake.
It went up, reached a certain height. We said that height is 20 meters. It's positive, it's above the ground. That makes sense to me. So I think that that is a reasonable answer. So I'm going to present my answer saying the y max is 20 meters. And I'm going to box it, and that is my answer. Alright, part B is asking us how long does it take the Cheeto to reach its maximum height? So the nice thing is that I don't have to redraw my picture. The only thing that I can add to it is what I solved from part A. And what I solved from part A is that the maximum height is 20 meters. So now here I can write that y max equals 20 meters. And so now we can use what we found in the next step, if we need to. I have a picture. I labeled my knowns. What is the target for part B? The target is the time it takes the Cheeto to get from the ground all the way to the peak. So I'm going to call that T1, and that is our question mark.
I need an equation!
So I know that I need time in my equation. If I'm looking for time, time has to be in my equation, which automatically gets rid of the last equation as an option because there is no time in it. So I could use the first equation or I could use the second equation. Honestly, you could use either equation. However, the first one is much easier. And you can tell that because in the second one you have a t squared. And if you use that, you're going to have to solve a quadratic equation, which is doing way more work if you can just use the first one. Alright, I'm going to plug in my zeros. My velocity at the top is 0 meters per second. That is my only zero. I'm going to rewrite it. And we're solving for T1. Alright, we're isolating our variable. Our target is T1, the time at the top. So I'm going to subtract v naught y, and to get T1 by itself, I'm going to divide by the acceleration. Okay, we have our variable isolated. Now we can plug in our numbers. T1 equals negative v naught y from our picture is 20 meters per second. So negative 20 divided by the acceleration, which is negative 9.8 meters per second squared. Again, to make it easier on yourself, you can use 10 instead of 9.8, and you should get about 2. Now again, this would be wrong unless you put your units. We're solving for a time, and time is measured in seconds. Now, before I'm done, I'm going to ask myself, does this make sense? We're saying that it takes 2 seconds for the Cheeto to get from the ground to its maximum height. That sounds reasonable to me. If for some reason you had gotten a negative number, you should definitely double check your work because time is always positive. My final answer is time is 2 seconds. Part C, how long is the Cheeto in the air? Now you really don't need an equation for this one. What you need to understand is that the time that it takes the Cheeto to get from the ground to its maximum height is the same amount of time that it's going to take the Cheeto to get from its maximum height back down to the ground. We just found the time that it takes to go up to the top. That time is 2 seconds. So, in order to find the total time, all I need to do is multiply that 2 seconds by 2, and that will give me the total time in the air. Our target, the total time. Alright, it's about time we got to this. The total time is equal to 2 times t1 that we solved for in the previous problem. So t total, I already have my variable isolated. I'm going to plug in numbers, 2 times 2, and I get 4, and this is time, so seconds. And that makes sense to me. The total time is twice the amount of time it took the Cheeto to reach to the top. So my total time is 4 seconds.